about the organization you represent.
Thank you, Jim. Thank you for coming this afternoon and allowing us to bring Mark Dorfman. And if you excuse me, I'm going to read a bit about this. Sometimes when you have a friend, we don't always know all these good qualities that I should know about Mark. Mark joined Inform in 1987 and now holds the position of Associate Director of the organization's Chemical Hazards Prevention Program. He's an environmental chemist with experience in industrialized and developed innovations. He received a Bachelor of Science degree from Rancho College, is that right, of New Jersey, and a Master of Science in Environmental Chemistry from the University of North Carolina School of Public Health at Chapel Hill. Quite a mouthful. But we have really critical problems here, and I'd like to feel that we are an ally with DEQ and that we are trying to all work towards down the discharges that are affecting the community, the people, and the workers here in the state. And I was very impressed with Mr. Dorfman's work. He's written on pollution prevention. I believe a paper that's going to be coming out in June that he's going to share with us. And I think probably I'm going to inform the good work that they do, in quote, if you don't mind the pun, to inform us about what's going on.
I'm going to stand way over here because I have some overheads that might, help illustrate what I'm talking about. Inform has been around for about 17 years. It's a nonprofit research and education organization in New York. And basically what we do is case studies. And there are several program areas that we work in, alternative vehicle fuels, and the project that I work in is industrial waste reduction. Specifically, we're looking at the extent to which companies, particularly chemical manufacturing companies, have avoided waste in the first place, what the results of those have been, and just what it is about those companies, what kind of programs that have enabled them to come up with these success stories. So, what I want to share with you the results of these case studies in a report that's coming out in June, and we hope to be doing it in June, so one way or another you'll be hearing a lot more about this report, which is called Environmental Dividends of Waste. I'll try to run through this at a fairly quick pace because I'd like to leave time for questions. I just want to emphasize that what Inform researches and reports on is source reduction. Those techniques that are going to avoid the creation of waste in the first place, because waste not created does not have to be treated, recycled, stored, transported, whatever. So here's a list of what those special features are. Is there some way of shutting just these lights off?
Yeah.
It's truly a preventive approach. It's multimedia in that it affects waste that would go to air, water, and land. It reduces risk to workers. And in turn, if you reduce risks to workers, you are probably going to be increasing productivity and reducing liability. There are many cost savings associated with source reduction, costs that would otherwise have to be spent on replacing materials that were lost because of poor techniques, and those can be either raw materials or products that are being lost. Lower environmental handling costs, treatment, disposal, and such. Lower compliance costs, the cost of staff time and such, and reduce long-term liability, whether it be associated with waste or worker health. And what you will see from the examples that I'll give you is often very simple, straightforward technologies that are already available and have been available for a long time to industry. Just briefly, and I didn't pass them out, but I put together a one-page handout, which I call the 3 A's of source reduction. Yes, pass them out. And it's just a synopsis It's avoiding, achieving, and anchoring. Avoid creating waste, achieve results, and anchor source reduction as a primary waste management strategy. The whole presentation that I'm giving today is sort of boiled down into there, but I thought you could look at it while I'm talking. But the first part, the avoid, just basically lists these things. Source reduction techniques are operations changes. That's changes that can include the way you handle materials, the way you transfer them, the way you maintain equipment, the way you clean equipment. Process changes, the way you measure the efficiency of your process, optimizing temperature and pressure and such, or rearranging the certain steps of a process so that you generate less waste. Equipment changes, such as adding condensers so that fugitive emissions are captured and put back into the head of the process, or removing equipment that was not operating efficiently. Chemical substitutions, which are replacing the toxic and hazardous substances that are currently used with non-toxic or non-hazardous ones that provide the same function. Or finally, redesigning, reformulating, or changing your product to a product that still serves the same market but does not require the same raw materials that might be toxic themselves or result in toxic waste generation. And I'm sure you're all familiar with the waste management hierarchy that's been accepted by environmental groups, by government, by international organizations, by organizations like Greenpeace, with source reduction on top, then only followed by recycling, treatment, and disposal. And as I'm sure many of you know, when it comes to the actual practice of industry, it's very often been the other way around. Now, the results that I'm about to share with you are from two sets of studies that informed it on 29 organic chemical manufacturing plants in 3 states, in California, Ohio, and New Jersey. The reason those 3 states were selected was because this research started about 10 years ago, and at that time we didn't have a toxics release inventory, and the data that was available showed California, New Jersey, and Ohio to be the 3 major hazardous waste generating states. If we were to do this kind of research again, we would certainly pick Louisiana as one of those states to pick plants at. So we selected 29 plants that would more or less be representative of the organic chemical industry in this country, by size, by type of product, by type of processes, batch or continuous, by the type of market they serve, and by the types of products they produce and the type of ownership. So there were some large plants, small plants, and medium-sized plants. And altogether, we were able to identify 181 separate source reduction actions that these companies took. And we were then able to take the results of these 181 and analyze them to see what the effect, what the impact of source reduction was been. So one of the most interesting things was that 87% of these source reduction activities fell into what we're calling the efficiency or housekeeping type changes. Basically being more efficient in converting currently used raw materials to currently produced products. Only 13% of the source reduction activities affected what is probably the more innovative and more research development intensive, is the input substitutions and product reformulations. And one thing this tells me, since this data covers all the way up to 1990, is that the more companies look for ways to reduce waste, the more they continue to find these basically simple, straightforward technologies. It's not that all of those have already been done, and all that's left is the innovative research and development types. There's still a lot of opportunities for off-the-shelf type of simple technologies. So I'd like to share some of the the examples that we have, just to give you an idea, one of the plants we studied was a Rome-Poulenc plant in New Jersey, which there is a medium-sized plant. It produces aroma chemicals, rare earth compounds, and some chemical intermediates. They installed inline condensers in a process which involved drying, and in the drying process, they would very often lose some of their product to the air. So they simply installed a condenser to capture some of this product that was being lost to the air, which effectively increased their yield. It cost them $10,000 to install the equipment to capture this fugitive emission, but they saved $30,000 a year because they are getting more of their product into the market. Merck is a large facility in New Jersey that produces pharmaceuticals, and what they did was install equipment that improved a purification step in their production of an antibiotic. They reduced 9.7 million pounds of methylene chloride per year, which was a 50% reduction of that particular waste stream. It cost them $1 million to do this, but they saved $1 million a year in various waste-related costs. Aristech, a plant in Ohio that produces cumene, bisphenol A, alpha methylstyrene, phenol, and acetone, they installed additional reactors on their units that produce phenol and BPA. And basically what that did was increase the reaction time between the raw materials. And the longer reaction time you have, the more conversion of raw materials into products you're going to get. So by increasing yield, they were able to save $2.4 million because they were producing more product from each pound of raw material. And it cost them $7 million to install these reactors, but that's just about a 3-year payback time, which in industrial circles is still considered a short payback time. I have many other examples, but one other one is from an Exxon plant in New Jersey, which produces fuel additives and synthetic lubricating oils and such, mainly through batch processing. And batch processing usually is associated with more waste generation. What they simply did was change their scheduling of products so that they were producing more of the same products in a row, which reduced the amount of times that they had to clean the equipment. Very simple. But by doing this, they were able to reduce 7.5 million pounds of waste per year from this from the lubricating oil additives process. And it saves them $1.2 million per year. This slide shows overall the amount of waste that was reduced per plant or per source reduction activity. So most of them, about 1/3, were able to reduce between 10,000 and 100,000 pounds of waste that would otherwise have been generated. Altogether, 2/3 were able to reduce between 10,000 and 1 million pounds of waste per year. Now that's a little bit difficult to really conceive of because, as I said, our research started before the toxics release inventory. The toxics release inventory collects data on the amount of the chemical constituent itself that is going into the air, the water, or the land. Prior to the toxics release inventory, for the most part, information on hazardous and toxic waste was by waste stream. So not only did you have combinations of chemicals in a waste stream, you had water or soil or something, some inert ingredient that was a part of it. So these pounds include both constituent and inert constituents as well. But one way to also see the impact of source reduction is to look at the percentage of the targeted waste stream that was reduced. Fully 1/3 were able to completely eliminate the target waste stream that the source reduction activity was targeted at. And 51%, just over half, of the source reduction activities at these plants reduced between 90 to 100% of the waste stream. Now, no matter what kind of ratio there is between inert ingredient and constituent, if you're reducing between 90 and 100%, that shows quite an incredible impact of source reduction. One example I'll share with you is a Dow facility in California. This facility produced a variety of chlorinated organics and chlorine and sodium hydroxide and various other things. And what they would do is take chlorine that was produced in one part of the plant, react it with hydrocarbons to come up with chlorinated organics. And there was hydrochloric acid that was given off as a byproduct of this as a gas stream. And what they used to do was just take sodium hydroxide as sort of a scrubber and capture all of this hydrochloric acid, converting it into brine. Now, they also had a brine plant on their facility that would take brine and convert it into chlorine and sodium hydroxide, and the chlorine would then be used in this chlorinated organics plant. Unfortunately, they could not use all of this brine that was being produced by cleaning up this acid gas because of the high concentration of hydrochloric acid in the gas. They had to use a lot of sodium hydroxide, which produced some sodium chlorate, which made the brine stream not suitable to be used to produce chlorine. So they had to build these evaporation ponds to send this contaminated brine to just evaporate and take the sludge and dump that. What they did was change this to a two-step scrubbing process. So they would scrub this acid gas stream first with water. The water would capture a certain amount of hydrochloric acid. It would be a relatively pure stream. They could then use the hydrochloric acid in other parts of the plant or sell it as a product. The part of the hydrochloric acid stream that, well, the hydrochloric acid that was not captured by the water now was a smaller concentration of hydrochloric acid. They could use a smaller concentration of sodium hydroxide. So the brine that formed from that was free of those impurities. All of the brine now could be sent to the chloralkali plant to produce chlorine and sodium hydroxide. In other words, they completely eliminated a waste stream from this process. It cost them $250,000 to institute this change. They reduced 12 million pounds of brine waste that they were producing otherwise, and they saved $2.4 million per year associated with all the evaporation pond costs, and they were able to close the evaporation ponds. And this whole source reduction activity took 4 months to implement. And this is not an unusual story in all the source reduction activities that we looked at. Simple technology in a short time saved a lot of money. A couple of other examples. A PMC plant in Ohio, they reported 6 source reduction activities to us altogether. 3 of those completely eliminated the waste stream, one of which was trichlorobenzene. And the reason they started looking at how they might be able to reduce trichlorobenzene was that they were discharging that to the local sewage treatment plant. And workers at the local sewage treatment plant were getting sick. And they finally were able to trace that back to the trichlorobenzene in the water. And the PMC plant, well, the sewage treatment plant put pressure on the chemical plant to reduce the amount of TCB it was sending to the plant. So the plant looked at what was it about their processes that was generating this TCB. They were able to make some process changes, which they did not share with us, but it was able to completely eliminate that stream. And perhaps that opportunity was there all the time, but they did not make the effort to find what was causing it until some outside pressure forced them to. The next slide shows that the impact of source reduction is pretty well even regardless of whatever type of waste you're dealing with. So overall, with air emissions, wastewater, or solid waste, or combinations thereof, you were getting at least on average a 70% reduction in waste of the targeted waste stream. Another interesting finding was that if you looked at the average amount of waste reduced per source reduction activity over time, you do see a fluctuation, which is not all that surprising because a plant is not necessarily going to find source reduction activities that reduce a lot of waste every year. But what is interesting about this, because a lot of times the argument you get from industry about promoting source reduction, they say, well, you know, we already did everything that's easy. You know, to get that last few percent is going to cost a lot and such. But what we found was that the more plants continue to look for opportunities to reduce waste, they continually find, even in the latter years, opportunities to reduce large amounts of waste. And also, one of the most compelling arguments for source reduction being aggressively pursued by not only the plants but by the regulatory agencies is the amount of dollars that can be saved. Most of the source reduction activities fell between $16,000 and $350,000 saved annually per source reduction activity. And there was only one of all 181 source reduction activities that resulted in a net cost increase. And this was a plant that went from a chromium corrosion inhibitor to a non-metallic inhibitor, and so their waste treatment cost went up. But in every other case where there was cost savings data, there was a net cost savings. And I'll come back to some savings information. These two slides show what kind of capital costs are required in the source reduction activities that we looked at. One of the most impressive things is this bar right here. This shows that fully 1/4 of the source reduction activities required $0 in capital expenditures. The largest fraction was between $10,000 and $100,000 a year, but what you can see from this, I'm sorry, $10,000 or $100,000 once, not every year. But what this second graph shows is the average payback time for source reduction activities in that category. So even those that cost between $10,000 and $100,000, on average, paid back the expenditures in about 18 months, a year and a half. And all of these are quite low, no matter what was spent. This one source reduction activity out here that cost about $19 million was by Exxon, where they changed the process where they were taking solids out of their lubricating fuel additives. What they used to do was just filter them, but in the filter you're also losing product. So they changed to these centrifuges, so the centrifuge would just get all the solids down to the bottom. You wouldn't be losing much product. So even though the centrifuges are very expensive, there was a net savings, but because the centrifuges are so expensive, this was about a 12-year payback. But the vast majority are a much lower payback. And I have another slide that shows the average payback overall. If you average them all together, the average month payback, 2/3 pay back the initial capital investment in 6 months or less. And 81% of all these source reduction activities resulted in a payback between 0 months and 3 years. And as I said, 3 years is considered by industry to be a short payback time. 81% in less than 3 years. So simple technologies and done quickly and cost savings, but we also looked at the effect on product yield, the efficiency of converting product from each pound of raw material. So for a total of 70 of these source reduction activities for which we could determine what kind of impact there was, 68 of them, or 97%, resulted in an increase in yield, more product per pound of raw material used. There were 20 of these that actually gave us a numerical amount, and if you average those all together, it was an average about a 7% increase in yield annually. It ranged from about 0.5% to 40% yield increase. And this next slide shows the average time to implement. Again, 2/3 were implemented in 6 months or less. And 94% were in 3 years or less. So this is quite impressive for how quickly you can reduce the amount of waste that you're generating and save money and all these other things that I've showed you today. We also looked at what was motivating plants to make these changes. The cost of waste disposal was by far the most often cited reason for them to finally say, where is this waste coming from? We've got to reduce it. The next was environmental regulations, and those are not regulations calling for source reduction. They're regulations that restrict land disposal. They're stricter limits on discharges to wastewater treatment plants, that sort of thing, that has motivated plants to start looking for their opportunities. Product output, I mean things like improving product quality or reducing or the request by customers in certain cases. For example, the electronics industry requires very high quality, high purity products from chemical plants. So those sort were the third, and then liability, and then other factors. When we looked at how these motivating factors changed over time, if you looked at the reasons stated in the first half of the 1980s and the second half of the 1980s, all of these resulted, or all of these reasons became even more pronounced in the second half, but by far environmental regulations was the fastest growing reason for promoting source reduction. Now, this certainly suggests that strict enforcement of currently, or those regulations that are currently on the books can have an impact, but it's important to also realize that environmental regulations are not necessarily the only answer. And I'll come back to that as I'm talking about the barriers. I think many of you probably already know, and certainly from what I've already said, that the barriers keeping companies from doing more source reduction are not economic because they've saved a lot of money in a short time. It's not regulatory. If anything, environmental regulations for the most part have spurred more, and they're not technical. A lot of these technologies are very simple and can be done in a short time. The obstacles were institutional. The companies were simply did not know where their waste were coming from in the first place until some outside external reason came about that made them question where is this coming from in the first place, to get out of that business as usual mentality. Here are some of the institutional barriers. Basically, a fear of change. These companies have been operating for a long time. They've been making a profit. They don't want to mess with something that's not broken, so it takes some sort of outside force to kind of get them to do what's actually in their own best interest. A belief that their processes are already running at optimal efficiency. But when these external factors come in and get a plant to start looking closer at its waste, in that board example, you can see how they could be operating more efficiently. No policy stating that source reduction was indeed on top of the hierarchy. no information gathering systems that they know where their sources of waste are, no cost accounting systems so that the environmental costs that have traditionally been an overhead of the whole plant, the operations managers of the individual operations did not know what the waste from their operations was contributing to the overall cost. And no reward incentive system for employees, whether they be management or operations workers and such, to first of all come up with ideas. I mean, they're working on these processes every day. They're intimately familiar with them. So very often there was just not a system of getting ideas from them, and then when these ideas were implemented and put into place, any kind of reward or recognition system for the success of the company. So what we did in this study was also look at to what extent these plants had a policy, had information collection systems, had cost accounting, were involving their workers. We also looked at whether or not they were setting source reduction goals, whether or not there was leadership, somebody in charge. And what we found was, if you just look at this half and this half, those plants that had 5 or more of any of these program features were 2.5 times more successful, or they were finding 2.5 times more opportunities to reduce waste than those plants that had fewer. And we also did a little bit of a statistical analysis, and we found that 3 of these features showed a statistical significance. So in leadership, if you had leadership that was a combination of plant management and the environmental departments, you had 2.5 times more source reduction than otherwise. And being that this was a statistical significant analysis, that means that 95 times out of 100, if a plant has this kind of leadership or these other things, that they will also increase their source reduction achievements by this much. Those companies with worker involvement, the reward recognition and such, had 2.5 times more, and those plants with cost accounting had 3 times more. And the information, the materials accounting wasn't on there, but 14 out of the 15 plants with the cost accounting also had materials accounting. So although we didn't find a statistically significant difference in those plants with and without materials accounting, it doesn't mean that there isn't a significant difference in those plants with materials accounting. It meant that our sample size, there were only 2 plants that didn't have some sort of materials accounting, so we weren't able to actually come up with that. But by association, I mean, and it only makes sense that you can't do cost accounting unless you have materials accounting in the first place. So in general, these plants that we looked at, 21 had leadership of some sort. Only 4 of them had the combined leadership, but 21 of them had leadership either from the environmental or the plant management. Materials accounting, cost accounting, and such. So you can see about half the plants did not have cost accounting, about half the plants did not have worker involvement. 2 of the things that showed significant difference. So if you look at this, which shows just the number of source reduction activities reported total over the year, the trend is that it's increasing. And all of the results that I shared with you were quite impressive. But if more plants had cost accounting, materials tracking, and worker involvement, these could be even further up. The amount of waste reduced could be even higher. The cost savings to plants could be even higher, and so on. So what was that bell the end of this? Oh.
The end of the class.
Oh, okay.
The classroom building.
So basically, what this research reveals to us is that anybody who's got an influence on what plants are doing should be, first of all, assessing and making sure that plants have cost accounting, materials accounting, leadership, and worker involvement. And if it's a regulatory agency, There are some examples of what's happening around the country, and in a state like New Jersey, I think, is most advanced in calling for pollution prevention plans, and what they call pollution prevention is the same as source reduction, from the manufacturing facilities in that state. And the plans have to include materials accounting and cost accounting, two of the major foundations of the achievements that we found. And I'd be happy to share with anybody here a copy of the New Jersey legislation, which is new, and the Department of Environmental Protection in New Jersey is only now coming up with rules and regulations. But it's a very interesting process, particularly because in New Jersey, relative to other states, particularly Louisiana, there is a fairly good amount of communication between the regulatory agency, the environmental community, and industry. So I would urge you to at least keep track of what's happening there. And for community groups, there is an opportunity for them in any negotiations that they have with a facility, whether there's a new facility that's to be sited, or they're trying to work with a facility that's already existing to decrease the emissions into the community, or the facility wants to build an incinerator or get a permit for an underground injection well or something. One of the first things they should do is make sure, if they can sit down and discuss with plant management, whether or not they have these materials accounting. Do they know where the sources of their waste are? Are they accounting waste-related costs back to the source? Are they involving their employees in the whole process? Do they have someone in charge? Do they have a written policy stating that source reduction is a top strategy? And with that sort of dialogue, and with some of the evidence from these case studies and case studies by other people, it becomes a much more compelling issue that whatever is trying to be done in the state environmentally, that source reduction be a foundation for it. I would be, well, Inform has a citizen's guide, which basically explains all the what source reduction is and these impacts and such. And it also has an actual questionnaire in it in much more detail about policies and materials accounting, cost accounting, etc., which can be used by community representatives. I think can also be used by regulatory agencies to find out what plants, or the plants that you are looking closely at, how close they're coming to having these types of program features. Because chances are, if they do not have these kind of program features in place, they are not identifying or taking advantage of all the opportunities that they have to avoid creating waste in the first place. And I'm not trying to say that I think that through source reduction 100% of the waste could be reduced, but this evidence is quite compelling that a lot can be reduced. It's good for business, it's good for the environment, and it's good for the community. I'd be happy to take any questions you have, and I also want you to know that we have a small grant from the J.C. Penney Foundation to work with, particularly with grassroots groups in Louisiana in promoting source reduction. But I and other people at Inform are available to them and to you in your efforts to promote source reduction. I work mostly with Mary Lee or Lean, which I think most of you are familiar with, so you can either contact me directly or contact me through Mary Lee. So thank you for your attention, and I'd be happy to take questions.
Mark, don't you think PRI mission data has gone a long way to providing one of motives and incentives to industry to reduce waste reduction?
Yes, I think it has, and I think it really shows the power of information, particularly publicly available information. And if TRI went further, it could do even more.
It is
Right
going
now,
further.
right. I suppose you're familiar with the Sikorsky Right to Know More Act and how that's trying through the record reauthorization to get even more out of TRI than what the Pollution Prevention Act of 1990 is getting. But yes, I think just the fact that they have to collect the information, in certain cases, that is helping industry to find out, how much they're actually putting out, and the fact that this data is publicly available. I mean, the whole environmental movement in this country is a result of community pressures, and I think we continue to have quite an effect.
Mark, I was curious, CMA has the CARE program. I think it would be an excellent thing if you talk to them, or the CMA, their headquarters in Washington, D.C., see if they can't go ahead and let this be one of their CARE programs.
Well, it is more or less. I mean, in the responsible care guidelines, they do address source reduction, and they do a better job than I thought they would have in saying just what source reduction is. Now, I think those guidelines could go further, and we do have a relationship with CMA to some degree. But one of the most powerful tools, I think, of the responsible care program is that, and you see these ads in magazines all the time, is that to be a member of CMA, you have to engage in dialogue with the community. Plants can interpret that any way they want, but that, I think, is going to be a powerful tool as well for getting companies to be more responsive and take a better look at source reduction.
In Louisiana, we formed the Small Business Advisory Council. Joanne Gardner works with us, heading up that effort. One of the first things that we're going to be doing is looking into providing assessments for small businesses where we can identify source reduction opportunities.
So you would be helping them help themselves identify these opportunities.
Right. Well, I don't know if we can go as far as to offer a stipend, but we certainly would be offering
Technical assistance. We're looking at a program that Alabama has in effect now whereby these retired engineers go out and do waste assessments for small facilities. They're coming here in May. You want to tell us how that program works, and we may adapt parts of that for Louisiana.
This has a very high priority in the governor's office. So I think you'll see a lot of, where the real need in Louisiana is in the helping the small businesses.
Why do you say that?
Well, because almost all of our large industry have environmental staffs, and they've demonstrated already that they have a good record of source reduction.
They've demonstrated that in
the reductions
information.
that we've seen in their TRI numbers and also in their waste reduction plans that they've sent us.
But do you know that the TRI reductions are a result of source reduction, or as we were talking before, treatment?
Right.
Or
No, it's, we have to take the word for where the numbers come from. We can't enforce, we're not planning on using that for regulatory activity to achieve source reduction. We're trying to achieve it in this state on a voluntary basis.
well,
Have you
these,
seen those publications we put out showing the plans of the industry to do this? Have you seen that?
No, I haven't.
Corporate challenge.
Corporate response, corporate challenge. If not, it's available, so if you follow us up to our office, we give you.
is this something that's being discontinued through the new administration? I know there are some things that seem to be falling by the wayside.
Despite what you've heard.
So the companies will continue to be doing plans.
Isn't there a grant based on TRI data for them to use the information on this data farm R to go back and double check the
Yeah,
information?
right, that's,
That
Right.
grant is ongoing, isn't it?
right. We're going to be also looking for outliers for the TRI reporters. And those that are identified, we will follow up and see the rationale for why they are, whether there's been some non-compliance
You mean with non-compliance with TRI?
with their permits.
No permits. Okay. That's kind of like a proposed TRI
Also,
You tell it better.
looking at a statistical study to compare TRI data with curriculum data and identify whether a relationship exists where you can then correlate TRI with curriculum and see. Also